Hi everyone. In topic 1, take 1, or part 1, I guess we should say, I discussed a lot of these, a lot of this vocab words. A couple things we didn't discuss in there was just making sure that you know what an outlier is. You need to have the outlier rule memorized. So the outlier rule is, and write this down right now, so get out a piece of paper and a pencil, and write this down if you don't have it down. You should have the upper fence and the lower fence. The lower fence is quartile 1 minus 1.5 times the IQR. What's the IQR, you're wondering? That's quartile 3 minus quartile 1. The upper fence is quartile 3 plus 1.5 times the IQR. If something's above the upper fence or below the lower fence, you either have a lower outlier or an upper outlier. Another thing we didn't discuss as much on the definitions was the z-score. And the z-score is your observation, whatever that is, so it's a statistic or whatever you observed, whatever data point you observed, minus the parameter or the mean, divided by the standard deviation. You need to be able to interpret the z-score, so make sure you have this written down if you don't know how. Interpreting the z-score is, if I have an observation of 5 and the z-score is 1.2, I would say I am 1.2 exact standard deviations above the mean. All right. We should have talked about know how the mean follows skewness, but the median doesn't. I think everything else we have on here, and we're going to move on to the problems now. If you don't know how to make a box plot or a dot plot, make sure you write that down and talk to me. You can easily calculate a box plot in your calculator. You want to do the modified box plot with the 2 dots. As well as the dot plot, you cannot do in your calculator, and I always suggest using that dot plot for that t-distribution, which I discussed on the topic 4 review. Okay, so to the problems. The first problem, I want you to pause, and then I'll discuss how you do it. So pause right now, try it, and then I'm going to discuss. First problem. Concert attendance for a stadium is normally distributed with a mean with a standard deviation of 7,641. If a concert with 41,293 people in attendance is in the top 2% of all concert attendance records, what is the mean concert attendance? Well, I'm doing this at home, so I don't have the ability, or I can use my smartboard here, but it's not as nice. What you would do here is you're going to draw the curve. Anytime you know something's normally distributed, go ahead and draw that curve. Okay, so let's do that now. And like I said, I can't do it as great as I would do on the smartboard. Okay, so there's my curve. I go back to my problem, and I see that we don't know the mean. It's asking for that. Okay, so that's going to be my question mark. I know, though, that I have 41,293, and I know that that's in the top 2%. So that's above my mean right now. Okay, so I'm going to mark my mean. And then we said that the top 2%, so that's over here somewhere. And that's this area. Okay, so this we know is 2%. Oops. Which makes the rest of the area 98%. Okay, so that's all this area. So I'm going to go to my z-chart now, and I'm going to find the z-score for that area. Okay, so when I go to my z-chart, I'm going to go right here, and I'm going to look at 98%. What z-score gives me a 98 percentile? So 98 percentile is somewhere around here, and you can see that I'm probably going to get closest at, let's see, we're at 98.03, 97.98, and that's going to give me a z-score of 2.05. 2.05. So I'm going to go back to my picture. This z for 2% is 2.05. How did I find that? The z-score only works to the left of the curve, okay, or the left of this line. So I have to look for 98 percentile in my chart, go backwards and find that z-score. Next, I know my z-score is equal to my observation minus my mean divided by my standard deviation. I know my observation, and I know my standard deviation, and I know my mean. My observation, I believe, was, let's see, we got to get it exactly. Oops, wrong one. Was 41,293. Okay, so let's write that down. 41,293 minus my mean divided by my standard deviation. And my standard deviation was 7,641. And the question is asking, what is the mean? So now I'm going to use algebra, and I'm going to solve for that mean. I need to isolate the mean. So first I'm going to multiply by 7,641 to 2.05. Then I'm going to subtract 41,293. You're going to get a negative number. That's okay because the mean is negative. So we divide by a negative. And the final answer should be A. I'm struggling to highlight it right now. So A. Pause it right now, write down any questions you have, and bring that to me tomorrow. All right, the next one. The following dot plots show the mean temperature in degrees Fahrenheit for a sample of cities in North America. Both January and July temperatures are shown. What is one statement that can be made with certainty from the analysis of the dot plots? So why in July than in January? No, that's not true. You can see we have some higher temperatures in January over here than July. So A is not true. B, the distribution of temperatures in July is skewed right. Well, the distribution of temperatures in January is skewed left. The distribution of temperatures in July is skewed right. That looks pretty symmetric to me. The distribution of temperatures in January is skewed right. Again, if anything, this is maybe a little skewed right, but again, I'd say that's pretty symmetric. C, there's more variability in average temperatures in January than in July. This is for sure, we can say this with certainty. We go from 5 to 75. The variability there is much larger. The range is much larger in January than it is July. So, with certainty, we can say C is the correct answer. Number 20. Please read through it, pause, and then I will go through it in a second. The following graphs show the vitamin A content in international units for 23 types of fruit. Which of the following would be the best measure to describe the center of this distribution? This distribution is skewed right, and as a result, we want to use the median to describe the center of the distribution. The standard deviation is a measure of spread as well as the IQR and the range. Number 36, again, pause, and then I'll talk about it. The weights of women are approximately normally distributed. This week, the z-score of a weight for a member of a weight-watching group is 1.25. Which of the following is a correct interpretation of this z-score? This week, the member weighs 1.25 pounds more than last week. No. B. This week, the member weighs 1.25 pounds less than last week. No. C. This week, the member weighs 1.25 more than the average woman. No. D. This week the member weighs 1.25 standard deviations more than she did last week. No. E. This week the member weighs 1.25 standard deviations more than the average woman. This is correct. Your definition of a z-score is the exact standard deviations above the mean. Okay, 39. Pause it, try number 39, and then we'll discuss it. 39 takes the longest, in my personal opinion, because there's so many things that it could be here. We have a hard time eliminating. The first thing I would look at here would be the median, okay? So the median is around 10-ish. Well, A, it's at 9, B, it's at 9, C, it's at 9, D, it's at 9, and E, it's at 12.23. So we can eliminate E right away. That doesn't help us a whole lot, but it helps us a little bit. So I'm going to get rid of that right away. Okay, the next thing I'm going to look at is I'm going to look at my quartile 3. That's pretty easy to see. Quartile 3 is at 20. So A is at 20, B is at 20, C is at 20, D is at 20. That doesn't help us a whole lot. Our quartile 1 looks like it's in between 0 and 5 somewhere, okay? Quartile 1's at 2, 2, 2, and 2. Again, this does not help us. Okay, so the next thing we want to look at, we've looked at quartile 1, we've looked at quartile 3. We could look at the min and the max. If we look at the min and the max, I'm not certain that will help us much either. Our maximum is 50, our minimum is 0. 0, 50, 0, 45. Eliminate B, okay? 0, 50, 0, 45. Eliminate D. So we're in between A and C right now. Your maximum on an output is still going to be the maximum value, even if it's an outlier. Okay, so we're at A and C. Well, now what are we going to have to look at? What's different between the two? And it looks like the only thing that's different between the two is the mean. 12.23 here and 9 here. And I want you to really look at the mean and the median here. They're equal to each other. But we have an extreme observation. And we have a tail on the right-hand side, which means it's skewed right because of that extreme observation and that tail there. As a result, the mean chases the extreme observations, and when it's skewed right, the mean is greater than the median, which means my final answer is A. And that's all I have for topic 1, univariate data. I'll try to get topic 1 bivariate data here in a little bit.